Hello all, a warm welcome to everyone tuning in to this Oracle IAM Insights session today. I'm Brad Donison, a Senior Principal Technical Support Engineer, and I've been with Oracle for over 10 years now in the identity space. Today in this session, we'll be covering more container-related topics as we work our way through a demonstration of an actual deployment of Oracle Identity Governance inside Docker containers. We'll start out with a brief recap from the previous video. Then we'll move right into creating OIG containers and following the online tutorial. In the previous session, setting up OIG containers, we briefly covered some of the basics, some requirements and options. We also reviewed my container system to make sure that it was operating as expected. This demo will show all the commands necessary for creation of containers, where the logs are, connecting to a running container, and other such fun stuff. We'll see the ports exposed by the containers, check out the proxies, run a few sanity checks, and the starting and stopping procedures. Fasten your seatbelts. This is our system that we're going to take a look at. The one we're going to look at is the Oracle by Example tutorial for Docker containers. We've done some of the preliminary steps here. We've talked about the database and things like that. We'll get up to the point where we validated that the OIG image is deployed. So here we have the database image. We've got a couple of connectors that I've downloaded as well, and then images for OIG. So the first thing we'll do is we'll load the database image. And again, we see this is just a brand new, fresh setup. And now we want to tag it. We want this to be not none and that to be not none either. So we're going to do what's called a tag. We're telling Docker to rename this image ID, and we're going to give it localhost Oracle database. And the version is going to go into the tag here. Now, if we go back and do a Docker images, bang, there we have it. In the Docker compose steps, we're going to be referring to localhost Oracle database : 19300-EE. So it knows which image to use. We're going to take this patch and unzip it. That was just straight download from Moss. Now we have the OIG tar file, which is the Docker image. And from that image, we will make the containers. Now, it's always important to read whatever README files are included, so let's go ahead and do that. And here we go. We see that this image contains the OIM bundle patch from October of 2020. It gives us some additional information. And then it shows us how to load the image tar file into the repository for the Docker setup, which is very similar to what we did with the database. So let's do the same thing with this tar file. Here we are. Oracle OIG is the repository, and the tag is the version number 2000, November 16th. Let's clean things up a little bit. Let's go back to the Oracle by Example tutorial. It just wants us to verify that the OIG image isn't actually loaded, which we already did that. Date and the size and the version number is a little different, of course. Now let's carry on to step number 2, or phase number 2. And we're just going to go through these steps here. So for a work directory, I'm just going to generically call it OIG containers. I'm going to cd into that directory. Now I'm going to do the clone step. This is basically going to download a number of scripts, associated config files. And then let's cd into it. Now we're going to be making some edits to it. So the first thing I'll want to do is make a backup. Let's take a quick look at this before we make any edits. So we see we've got user home directory. This will be where the domain and the database will be loaded up, all the data files, anything that's going to be local to this machine. Where's the registry for OIG and the database and the version. If we need to set any proxy variables, database information, how do we connect to it? And here it uses the convention of listing the name of the database container, assuming that that's what you're going to be using, but that may or may not be the case. Some password information, the OIG image. So we're going to need to update that as well. The schema prefix, it's going to go ahead and run the RCU automatically. It's going to test, of course, and see, has the RCU been run already? Then it's going to create some directories. And this is all working towards setting up a whole bunch of environment variables. So the tutorial page here goes through and it has some examples here. Now, the one thing I do want to point out here, this gives an example of running the command. It is using the dot command notation. We are already in the Oracle Identity Governance location. Actually, one thing we want to do is make that executable. As the tutorial says, we need to run the setenv script as a dot command. This is different than simply running it as a regular script. We're not going to just call this and run it. If we want to run some script, we might execute something like / and then the script name. But this is going to run the script, execute all the commands inside the script, and then exit. The script does a number of exports, thus setting up environment variables. But if the script is run as a normal command, all those environment variables will be defined only for the time that the setenv.sh script is actually running. After it exits, any variables that it sets are gone because the script was run within its own scope. It did not adjust any environment variables within the scope of this actual terminal session that we currently have open. So instead, the tutorial asks us to run it as a dot command, like this, dot space, and then the command that we want to run. In this case, the setenv.sh script in the current directory. What this tells the Unix shell to do is to run the setenv.sh command within the scope of the current terminal session. Do not create a new scope. Thus, all the calls to the export commands, they actually set the environment variables within the current session. I'm just going to check and see if there are any environment variables that contain DC underscore in them. And there's nothing. Let's just run this script directly. And we haven't modified it or anything yet. We'll go ahead and do that. But we see, let's take a look and see if it set the environment variables. And no, in fact, it didn't. So that's why we need to, instead of the /setenv, run it as a dot command, dot space setenv.sh. Clear this out. Now we can see it printed out some environment variables that we're using here. Database version, the location where our domain files will exist, fictitious host name here. This is where the database data will reside. Here's the host name for the database. Looks fairly good, but let's just verify that we actually have environment variables set up. Aha, indeed we do. Look at all these DC underscore environment variables. That's what we want. So as long as we stay working in this specific terminal session, we will have all these environment variables defined for us. Step 1 and step 2, or phase 1 and phase 2 have been completed above. To phase 3. And actually this first step here, we've already done that. We've tagged the Docker image for the database already. So that's already done. We're going to use a Oracle database that's running inside a Docker container locally here. But that's just one option. There's an option for using an external database, and we could choose to go that route instead. We're going to do it right here within a container. So we will just sort of follow the rest of these steps. But before we run the next step, the docker-compose command, a quick word about name resolution. Back when we edited the set-env script, we had set the database hostname variable to a fake hostname, in this case, something in the example.com realm. In your case, you might instead use a static IP address, or you might have database on a physical host, and it's got a static DNS hostname. Instead of that, either of those, we put together a fictitious hostname of database.example.com. And that will actually be the hostname that we'll use for the database container. Now, if we had specified, an IP address or something that will resolve via DNS without any problem, or actually the container name for the database, which in this case is OIMDB, then we wouldn't need to make any changes. In this example, we've chosen to use a fictitious hostname. For the network connections to work, we would then need to make sure that the /etc/hosts file gets populated with the IP and hostname for the database server for each container. Otherwise, database connections would fail. We can do this by editing the YAML file here, docker-compose.yaml, and adding a couple of lines here, tagging extra hosts that will be added to each entry. Before we go ahead and run the docker-compose up-oimdb, we're going to make some modifications to this YAML file that we see here. And let's take a quick look at it before we modify it. So there's the section for the OIMDB. And we will be adding the extra_hosts section there. And then I will have to do the same thing for OIMadmin, which is the WebLogic administration server. And there's the SOA MS, the SOA managed server that's going to be created. And lastly, the OIG managed server, or we call it OIM-MS for short. Now we're going to add a couple of hosts here. We want to add the database.example.com host, which is already in the etc host file for the parent system. And we also want to put in the containers.example.com, which is this machine here that we're working with. We want these two IP addresses to be added to the host file in each container as it's created. So let's go ahead and do that now. Just going to yank these lines right at the bottom of that section. Now we can verify this little command. Now there we see our extra hosts. Now this IP address here, it's the IP address that is automatically handed out to the first container that's created. So the first container that we're going to be creating is the OIMDB container. There's no containers running. There are no containers created yet either. So we're going to move on to the Docker Compose. There we go. So what this is going to do is this is going to create the container. Let's take a look. This Docker PS shows us all the containers that are running. This is the container name. Here we have the status. The health is starting. Let's quickly check to see what the IP address is, just to verify and make sure it is that. Is it 172.18.02? We are going to inspect the container, OIMDB. Good. There we are, 172.18.02. So there's a whole bunch of other information it would have spit out, but I was just interested in what the IP address was. So we're good. Now we can actually connect to a running container and run commands. So why don't we give that a try? We do that this way. Docker exec. I'm going to run interactive shell. We're going to connect to the OIMDB container. And we're going to run a command. In this case, let's just run the bash command. Now let's see what the etc host file has to say. See, there's an entry for database.example.com and an entry for containers.example.com. There we go. That'll help out a bit. I wonder if PS is installed. Yep, it is. So we are inside the container, and we can see that the database is running. So it's actually a brand new database that's being created right now. Let's exit out of the container. So we are no longer inside the container. We're back in our shell. Let's take a look, see if we have any proxy commands yet. Yes, we do. We've got Docker proxy commands for port 1521 and 5500. Any network requests that come into this system that we're on right now will be redirected via this Docker proxy process. If it's coming in on port 5500, which is the EM port, or on the listener port of 1521, it's going to automatically redirect that traffic to the container, which is running on this IP address. Now, if you remember, up front, or way back, after we created the container, came back saying the container was created and it's done. Now, just because the creation of the container is completed doesn't mean that the setup and the services are ready for use. You might recall from the Docker PS command, the health shows that it's still starting. We want to see that in a healthy status rather than starting. So before we continue with creating other containers, Docker logs -f and then the container name. So here we go. We see that the listener is up and it is creating the database instance. So this is going to take some time. After this, then it'll do some post-creation steps as well. I'm going to fast forward 20 minutes or so. Good. It looks like the database is ready. Let's just exit out of this. This is what we're looking for. Status, healthy. Let's see if we can connect to it. Test is success. Awesome. That is done. We've taken a look at the logs. Database is ready to use. Now, we specified in the environment variables the actual password that we're going to use, so you don't even need to worry about steps 5 and 6. We're going to move right on to the WebLogic admin server. Now, we are already in the containerized DB directory. We are ready now that the database is up to run the next Docker compose command, which will create another container for us. We still have one container only. Now the container is created. You can see a brand new container. It's just starting up. It's called YAML admin. Let's take a look at the logs. There we go. Now we see one of the first things that it's doing is it's running the RCU. We didn't go ahead and do all the prerequisites. You should probably do that. There's a couple of things that it's going to complain about. While that is carrying on, let's take a look in the domains directory. This is the location we specified in the setenv script. You see that there's some data directory. There's some config files for our database. There's the actual database files. They aren't in the container, so the container could be upgraded, could be wiped away and recreated, and that wouldn't affect our data. Our data will remain intact. And that is the same for the OIM domain directory. And it's still running the RCU step. So we'll let that complete. And after the RCU is done, we'll actually use WLST scripts to create the domain, and then it's going to start up the admin server. So we'll fast forward through this. Okay, the RCU is done. And we can see it's now running some WLST, some Python scripts or Jython scripts to go ahead and configure the domain. Now this happens only just during the first startup. Of course, it's going to configure the domain every time. Check to see if the domain is already configured. And if so, it's just going to start the admin server. If it's not configured yet, it's going to follow all the scripts to configure the domain and then start the admin server. So the WebLogic admin server is starting. It's not up yet, I don't think, but we shall check. You see the logs are listed here. Now this is relative to inside the container itself. In actual fact, the U01 Oracle User Projects Domains folder is mounted. It's a file share. And here's our domain directory now that the domain is created. This is the standard out log files, I believe, for the admin server. And the admin server is running. Now with all these Docker commands, be sure to run them in the same terminal window, because that's the window where we did the dot command for the setenv.sh. Otherwise, all the environment variables will be missing, and the automation scripts used to build the image files will fail. This is not for running any Docker compose command. So when we get to the next container, we have to be sure to come back to this tab. What I wanted to do is quickly do some updates to the database, set the processes and a few other things it was complaining about. Some of the tunings. Now these files are located right here. They will not be available to the container. So what I want to do is I want to copy those to a location where the database container can get to them. And that would be in that shared area where the Docker persistent volumes are located. There, I've got the SQL files there. Both containers are healthy. I'm going to connect to this one and see if I can see those files, which I should be able to do. Right there. And there are these files. So I'm going to change the permissions to these SQL files. Now we are inside the container. Here are these two SQL files that we copied across. Copy. And I like using SQL Developer personally. That works great. That's all good. We can disconnect. Now we want to run some similar SQL in here, except not as system. Copy and paste. Let's run all these. One of the other prerequisites before OIM, so get going, we need to run this SQL command. So we want to run this inside the Oracle PDB1. And we're done. So database prereqs. Now we've exited out of the container and we are back into the host machine right here. I don't think we need this tab anymore. We are back here. We have the environment variables still set. So we're in the correct session. Now the command for the SOA MS. Go to our work directory. Samples, containerized DB. There we go. That's where our YAML file is. And that's the directory that we need to be in when we call any Docker Compose file commands. And in similar fashion, the container will be created, but the services won't be ready yet. It is starting, and this will take some time to complete. We can track the process here. You see that it's going to run some more Python scripts to create the SOA managed server. And this would be the log file for the SOA managed server. And this will take a few minutes. I believe I saw that it was running. Yes, it is. We can stop that tail. All three are healthy. We've looked at the logs. We are now ready for one of the last steps. Let's create the OIG server, or in this case, it's the container itself is called OIM MS. Container is up and running. As normal, we can monitor the logs. After this, we can do some validation. Then we can do some stops and restarts. It looks like this is done as well. Let's check and see if it says that it's healthy. 4 containers, all healthy. Running, 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 all healthy. It's a good sign. And I should say that these passwords were the ones that were configured in the setenv.sh file. And there we go. What I wanted to cover is stopping in addition to starting. So we see we've got OIM MS, SOA MS, OIM admin, and OIM DB. We just go in reverse order. We stop OIM first, then we stop SOA, then we'll stop the WebLogic admin server. And lastly, we stop the database. Good. Now, if we want to start them, instead of stop, we do Docker Compose start. Fast forward. SOA managed server. We are now in a position to start the very last one. Thank you again for tuning in to today's Oracle IAM Insights session. We look forward to seeing you at the next one.